Good morning, Tahmina Khan is here with video number 3 on energy, work and power. In my previous two videos, I have explained the whole concept of the syllabus of A-level mathematics M1, the topic, which is from CAIE syllabus. And in the second video, I took two past paper and explained the concepts again. And now in the third video, I will again take 2 to 3 questions. Let's see. And then it will help me to complete the concept with the help of different examples. So let's start the question. This question is from June 09, question number 5. And in this question, it is talked about Cyclist and his machine. The total mass is 20 kg. Rather than reading the whole question, I'm telling you briefly, and then I'll keep using the information so it will not be boring for you. So Cyclist starts from here, free wheel, and the length is 250 meter when he reaches here, and this inclined plane is at 2.6 degree, and that is all about the first part of the information. Then it continues free pedaling, free wheel from here till here. When it reaches here, the velocity is 9. When it will reach at C, the velocity is 5 and distance is d. So understood, we have to find this distance. In the first part of the question, it is saying find out the gain in kinetic energy. So when object is coming from here to here, and find out the loss in potential energy. Definitely it is at higher place, so this place has more potential energy, gravitational potential energy. So these are the two questions, and then it is also saying find out the work done against the resistance to motion. So when it is coming all the way down, it is constantly facing a resistance. So rest of the question we will see afterward. Let's see the solution of this part first. Okay, just for convenience, I have written the information once again here, so that when I use the numbers, you can understand what I'm talking about. Okay, so this was the question. And I have to find the gain in kinetic energy. So what was the kinetic energy here? It was 0 here, and here it is 9 meter per second. So I'm simply applying the formula. Half mv square, mass was 80. So I got the gain in kinetic energy, which is 3240, right? Because initially u is 0, so this whole term will become 0. The second part of the question was saying loss in potential energy. So I will simply calculate this height. So before I show you, can you tell me what is this height? If you look at this, it will form a triangle, right angle triangle. You know this length, 250. So what this height will be? Yes, you are right. 250 times sine 2.6. So question is saying find out the loss in potential energy. So I have simply subtracted the potential energy at A and B. At B, because it was on the ground, it was 0, but at A it has certain height, so it has value. If you will do B minus A, it will be minus this. Now minus mean energy is losing. So when you write loss in potential energy, then you do not write here minus sign. That's why I have taken A minus B, right? So even if you do B minus A, for the final answer, remove the minus sign if you are writing loss in potential energy, loss in potential energy, then you will remove the minus sign. Okay, so what was the next part of the question saying? You have to find out the value of D, which is the distance between B and C. So for that part, we will use the law of conservation of energy. Total mechanical energy at A plus work done is equals to total mechanical energy at B. Now question was saying that the work done against resistance. Just a minute. Sorry, there was another question asked in part 1 which was saying what is the work done against resistance, right? So that's why I'm doing that mechanical energy at A plus work done is equals to mechanical energy at B. Now this work done against resistance. So basically I will subtract this, right? I will subtract the numerical value I will get over here. So after writing this formula, I will just substitute the values now. Kinetic energy we have just found. No, at A it is 0, so that's why this will become 0. And potential energy, did we calculate it? Yes, we did. Work done against resistance we have to find out, so we'll keep it as it is. And potential energy at B will be 0 because it is a level ground or the reference point. And half mv square kinetic energy will be 3240, which we have just found in part 1, right? So here I am substituting the values in the formula, and this will help me to get the work done against friction. You can notice here, because when I will subtract it, it will be minus, so minus minus sign will cancel out. When you will see at time when students solve question, they do not mention all this sign. They know the work done against friction means it is negative, so the value they will get, they will write it without sign. But when they will use it in the equation, they will use minus sign along, right? Okay, so what is the second part of the question saying? Let's go back to the question. Okay, so the second part of the question was saying the cyclist continues to freewheel along a horizontal straight path BC until it reaches C. So let me show you the diagram again so that you can understand. So once it reached here at the speed 9, it continued freewheel, reached till here, and the speed was 5. If you see, there is less speed, which shows losing energy on the way. And the question is also saying that the frictional force remain same throughout, right? It is written here in the question. Let me show you. Yes, the resistance to motion is constant, same as BD as on AB. So throughout the motion of the cyclist, the resistance to motion is the same, and we have to find the value of D. So this is part number 2. Let's do part 2. Okay, so in part 1 we have found work done against friction. Now if we use the same value, work done against friction, because it was the force of resistance was same, so we need to calculate that force of resistance basically. So work done is equals to, against resistance is equals to force for resistance force into distance. So in the part AB, the distance was 250 and the work done against resistance was this, which we have calculated. So this will help me to calculate the resistance force, which is constant throughout the motion. So now I will use this resistance force in my next part. Now I have to find out the distance D. So I am using the same work energy relationship, which is law of conservation of energy. Actually, what do we always write? Initial plus work done equals to final. Because it is a straight line, there is no question of potential energy, so I cannot write it, or I can skip it. So actually it is kinetic energy plus work done equals to final energy. So if I take this initial kinetic energy on this side and subtract it, what I will get? Change in mechanical energy, right? So new work done is equals to change in mechanical energy. So change ko we can also write loss or gain. We know here it is losing energy. So because energy the speed was getting lower or smaller at C, I just showed it to you, right? So work done against resistance is frictional force into distance, and frictional force we have just calculated here. Okay, and kinetic energy at B and at C. So I have subtracted and got this answer. Make sense? So this will help me to get the distance. Let's do what is part 3 saying. Okay, so part 3 of the question was saying that at point C, now the cyclist start pedaling and he generates 425 watts of power. And now you have to find out the acceleration immediately at C when it passes through C. What is the acceleration at that time? Okay, so let's go and see the solution of it. Now to calculate the acceleration, I need to know the force, right? And because the power is given to me and I know the velocity at that point, which was 5, and I have used it in the previous part also. So I'm using force is equals to power divided by velocity, which is helping me to calculate the force at C. And I have to calculate the acceleration there. So I'm using Newton's second law, F is equals to ma. Now this was the forward force, which was generated because of the power the cyclist was applying, and this was the resistance force we have just calculated in part 1, above part. So I'm substituting the resistance force because it is same throughout the motion, and is equals to mass times a. So I'm using calculating it, and it gives me acceleration 0.771. So let's see the next question now. I hope you understood this. The best way, if you get stuck somewhere, take out the copy, pause the video and start writing yourself. Then it will make more sense. This question is from November 16, variant 4.2 and question 6. In this question, a van is pulling a trawler and they are connected by a cable, an extensible cable. And the mass of van is 3000 kg and trawler is 500 kg. And they are moving with a constant speed of 25 meters per second. And both van and trailer are facing constant resistance, which is 300 and 100 Newton. So I have explained the whole question in the form of diagram, which is here. So the whole question is saying van is pulling trawler connected by an extensible cable. This is the resistance faced by each, and this is the mass of each, 3000 kg and 500 kg, and the driving force. So first part of the question was saying write down the power of the van engine, and second thing, tension in the cable. So let's do these two questions first. So this is the explanation. These are the information from the question, right? So I have to find out the power of van's engine. Whenever we see the word power, immediately the formula comes in our mind, right? Okay, so if I have to find out power of car's engine, let's go and see the diagram once again. And you know, this driven force is actually equals to power divided by velocity. Agreed? So I can say power divided by velocity minus 300 minus 100 is equals to ma. You know, I'm using Newton's second law, which is what? F is equals to ma. So F is basically forward minus backward is equals to m, mass of two object, because I'm taking as a whole the whole system basically, right? So let's see its solution, exactly what I'm telling you here. I have done it by two ways. Some people feel comfortable it is all written in one go. So basically it is Newton's second law, which is F is equals to ma, right? So driven forward force minus 300 minus 100 equals to 3500 and driven force is actually power divided by velocity. Why did I write here 0? Can you tell me why? Because it was constant speed, which means acceleration is 0. So this term will become 0. So after doing this, cross multiply and you will get your power 10,000. So this is how I have done. Here I'm not showing you, basically I'm doing stepwise, whereas I write this step better. Now the next part of the question is saying find the tension in the cable. When you have to find the tension in the cable, now you have found the power also. So you can just consider one part of the figure, either this part or this part, to calculate T. So I will use Newton's second law of motion, but I will consider forward force because I'm taking this part only, because now I know power of the driven force. So it's fine if I take part of it. I know tension, I will find out tension. Okay, so let's do by both ways. First considering this portion of the system, and then by considering this portion of the tension system, the tension should come same. See here, tension in the cable. Consider the force acting on fan, and then we will consider trailer also. Driven force minus 300 minus T equals to this, because on van there is a constant resistance of 300 and the cable is also pulling it backward, trying to pull it rather. And driven force is power divided by velocity. Velocity we know, power we have just calculated. Same acceleration 0 because it is on constant velocity. I got tension in the cable 100 Newton. Here by considering trailer. So F is equals to Newton's law, T minus 100. Now let me show you here. I'm doing this. T minus 100 is equals to ma, right? Acceleration 0, I got T 100. So let's see what is the third and the last part of the question. Okay, so the third part of the question is that now the trailer and van reaches to the bottom of the hill and the incline of the hill is 4 degrees centigrade. And speed is 25 meter per second, power by the car engine is 2500 watt. And now you have to find the tension in the cable when the speed of the van on the top is 20 meter per second. So let's see how we will do it. So here I have tried to explain the part 3 with the help of the diagram. It is going on the inclined plane, which is at 4 degrees centigrade. Sorry, 4 degree. And the rest of the information is exactly same. However, now backward there are 2 more forces due to weight. So we have done earlier, okay, how do we resolve the weight into perpendicular to the plane and horizontal to the plane. So exactly like this I'm doing here. This angle will be 4. This is parallel to the plane and this will be perpendicular to the plane, right? So this is the weight. So this portion will be 30,000 sine 4, 30,000 cos 4. This is 5,000 sine 4, 5,000 cos 4. Okay, so let's see the question. So what is the question saying? Find out tension and then acceleration when the speed was, I will see what was the speed given. Anyway, yes, speed 20. So now this is the information given to you. So basically, if you have to find out tension, you can pick up either this part of the system or this part because both have T. One thing I would like to tell you here, when we consider the whole system like I did in part 1 where I said driving force, I was applying Newton's law of motion, but I was saying forward force minus this is equals to ma, right? Why did not I consider T then? Because this T in this direction and this T in this direction cancelling effect of each other because it is same. So when we consider individual part for the system, we only take it as T. Okay, so this is what I have done here. F is equals to ma. T minus 100, I'm using the trailer part, right? T minus 100 minus 5,000 sine 4 equals to 500A. Now this is the weight due to weight, right? I have shown you in the diagram. So by considering, but the problem here is, this is perfectly fine. I have to find out T, but I can't solve this because I don't know A. So first of all, I will find out A. I will plug in the value here and then I will solve to get T. So now what I'm doing to find out A, I am considering the whole system so that I can ignore T totally. So I'm saying forward force minus 2 resistance force and 2 forces due to weight which are parallel to plane is equals to ma. Because you're talking about the whole system, so I will add the mass of both van and trawler, which is 3500. Now driving force I know is P over V, and power is given to us, velocity is given to us, so I got the acceleration from here, which is minus 0.4547. So we know gradually it is slowing down. After that I will just plug in this value of A in this equation to get tension. This is what I have done here. So I got tension 221.43. So let's see the last question. This last question is very interesting. Sometimes the students get stuck on it. This is question from June 12th. It is question number 6. Now it is talking about mass of a car, which is 1250, and it is traveling from bottom to top of a hill. The length is 400 meter. Sine alpha is 0.125 and resistance to car motion is 800. You have to find out the work done by car's engine in these two conditions. Number 1 condition, when the car speed is constant. Number 2 condition we will see in a while. So let's see number 1 condition. So what is given to you? Mass, length, resistance and sine alpha. Okay, so question was saying total mechanical energy. I am applying law of conservation of mechanical energy. Total mechanical energy, bottom of the hill, and this is top of the hill. And in between what is happening? Resistance, the work done by car's engine and work done by resistance. So by car engine it will be plus because it is helping it to move forward, and resistance is like it is opposing it, so it is minus. Because it was constant speed, so kinetic energy I am cancelling on both sides. Potential energy was 0 in the bottom, but it was mgh. I will just tell you what is that. And work done by resistance 400 by 800. 400 was the length, 800 was given to you in the question, right? So you simply calculated and you got work done by car engine is equals to 320,000. mgh, m was 1250, g is 10 and h is 400 times this, right? You want to see how did you get this h? Okay, so let's see. Here is the sketch of the question. Thing is going up like this. It was sine alpha here. So what this side will be? It will be 400 sine alpha, and sine alpha was given to you in the question. So it is 400 times 0.125. So this is how you have found the height which you are substituting here. So after that it is simple calculation and you got 945 kilojoules work done against or by car engine, sorry, right? Let's see what is the second and the last part of the question. Okay, in this question, in this part, the funny thing is, which I don't know why, but the students usually get confused, was the relationship. So question was saying that the driving force in the bottom is the car is initial speed is 6. The car's driving force is 3 times greater at the top of the hill, and its power was also 5 times greater at the top. So at the top, driving force is 3 times the bottom one, and power is 5 times, right? Okay, so let's put down the information here. Now question is saying initial speed is 4 meter per second and bottom driven force whatever, but the top is 3 times of it. Bottom the power P, top is 5P. So for bottom, from here I can write the power law. Power is equals to force into speed. And for the top I can also write. After that I am solving them simultaneously. I am substituting this value here, right? And then simple algebra, cross multiplication, removing the bracket, and I got the velocity v, which is 10. Okay, so now I have the velocity there at 10. And what I have to find out? The work done by the car engine, right? So again I will use the law of conservation of mechanical energy, which is the energy at the bottom plus work done and energy at the top. Now for the bottom, we know all this. We know the velocity was 6. We know potential energy 0. Work done by car engine, we have to find out. Work done by force or friction is this distance into force. And kinetic energy is this, and potential energy is this, because the object is going up. I have just shown you how we've calculated this. So I'm just substituting the values here. So after that I'm using algebra, simple algebra calculation, and I found work done by car is this. Thank you very much for watching this video. If you have learned any concept, if it was useful, press like and subscribe, and do write your comments. Your comments will help me to improve my videos. Thank you very much. Bye bye.